Welcome to the tutorial on semantic gaze mapping for ETG data in BGaze. In this tutorial, we'll cover the following topics. What is semantic gaze mapping? And how do you map gaze data? Let's start with an explanation of what semantic gaze mapping is. With mobile eye tracking, you get a different scene video for each of your participants. This makes it impossible to immediately see gaze information from all participants together, aggregated in one place. But that's what you want to know. Where were they looking most often? Which areas received the most attention on average? And so on. The solution is SMI Semantic Gaze Mapping. In most situations, you can determine one or more views that represent the important parts of the scene that you want to track for all participants. In the semantic gaze mapping process, you'll define these representative views, then map all the data from each of your participants to those views. After conducting semantic gaze mapping, you can analyze your participants' aggregated data in various ways. For example, you can draw a heat map overlaid on your representative view, showing how the participants' attention shifted over time. So how do you map gaze data? I've opened BGaze and loaded an experiment that's been created and worked on before. On the dashboard, you can see the stimuli, which are the recorded video scenes for each participant. Let's begin by selecting our first participant and opening up Semantic Gaze Mapping. The first participant's recording will appear in the right half of the screen. Now, we want to find the part of the video scene that has the data we're interested in. If I click here in the thumbnail area of the timeline once, and then just move my mouse over the thumbnails, I can quickly find the desired position in the video. To lock the slider, click again. In our case, I want to show the participant's gaze on the ketchup shelf. Below the thumbnails is the Eye Events channel, which shows gaze fixations as white bars. The fixations are important as we will need to map them to correspond to key areas on the representative view. In order to see each fixation clearly, you may need to increase the time window size so that it displays not just minutes but seconds. To do that, I'll click down here on the time window control button and select 1 second. To map the fixations, we need to select one representative view. In our experiment here, we're focusing on the ketchup shelf. Now, we've already selected the relevant scene in our scene video, so let's just take a screenshot from the video by clicking the plus button here. We've just created the first reference view, which we can now use to map the fixations. Now we're ready to start mapping fixations to our reference view. A fixation that has not been mapped yet is indicated by a dashed circle. Looking at the currently selected fixation in the video scene on the right, find the corresponding spot on the reference view on the left, then click there. You just mapped your first point. The cursor has now automatically jumped to the next fixation. You can then map that one, and so on, until you've mapped the participant's gaze throughout the interaction. You'll see that the mapped fixations in the event channel turn green. After you're done with the first participant, select another participant's video by clicking Change Stimulus here in the top right corner. Since you want to aggregate data from multiple participants on one view, you have to use the same reference view for mapping again. Repeat the process of mapping fixations as shown before. Once you've finished mapping fixations for all your participants, you'll have aggregated data available. That is, data for all the participants on one reference view. Here you can see this data visualized in a heat map. This concludes our look at the BGaze Semantic Gaze Mapping workflow, which allows for efficient aggregation and analysis of mobile eye tracking data. For more details, please contact support@smi.de.